Okay students, moving to the second chapter, you can see there. So that is human eye and the colorful world. So in this chapter we study about the human eye, okay, and various other things. So what are the topics that we discuss in this chapter is introduction, then human eye, working of human eye, persistence of vision, viewing different colors, power of accommodation of human eye, defects of vision, refraction of light through prism, dispersion of white light by a glass prism, composition of white light, visible spectrum, cause of dispersion, recombination of spectrum colors, rainbow, atmospheric refraction, in that stars seem higher than they actually are, that is actual and apparent distances. Advanced sunrise and delayed sunset. The sun appears oval at sunrise and sunset but appears circular at noon. Stars twinkle but planets don't. Next, scattering of light, Tyndall effect, blues color of clear sky, white color of clouds. The sun looks reddish at the time of sunrise and sunset. Danger signals are red. So these are the various concepts as well as the examples for those concepts. So we study in this chapter, that is human eye and colorful world. Now we shall study regarding the human eye. The first is the human eye, and this is the various parts that are present in the human eye which helps in the sensation of vision. Okay, these are all the various parts. So let us go in detail to the explanation. This human eye can be compared to a photographic camera. Just how a camera captures the picture of an object when the light falls on the object, and when the same thing enters the camera, how an image is captured. The same way the human eye is capable of capturing the image of a particular object, whether it is near or whether it is far, using the light. So that's why eye is very sensitive to light. Now, there are various parts as you can observe here. The first is the eyeball. You can see here. The first part is the eyeball. Now, this full curvature of the eye is called as the eyeball. Now, the outermost spherical shape, okay, it is almost spherical in shape. The eyeball is almost spherical in shape, and it is having the diameter of 2.3 centimeter. Okay, approximately 2.3 centimeter will be the diameter. So now this complete spherical shape is called as the whole symmetry is called as spherical symmetry is called as the eyeball. Coming to the second, that is cornea. Now what do you mean by cornea? Now you can see here the bulged part. Okay, you can see the eyes, that is the part which is bulged outside. Okay, that bulged part is called as the bulged curvature part is called as the cornea. Now this cornea acts as a window to receive the light coming from the object. Okay, the cornea acts as a window to receive the light. Okay, it receives the light coming from the object. So that is the function of the cornea. Okay, next, the third one is iris. Okay, now you can see here the third one is iris. This iris and pupil, they come together. Okay, now what do you mean by iris? Now you can see here this blue circular whatever I have drawn here. Okay, you can see here the layer which I have drawn in blue. Okay, now that layer is what we call it as iris, and in this iris is nothing but it acts as a circular or a spherical diaphragm, a thin membrane. Okay, it's a diaphragm which has a thin membrane and it is circular. You can see here that particular diaphragm is called as the iris. Okay, it's a circular diaphragm, and in this iris, as you can see in this iris, it is having hole in between. Means at this end where there is cornea, there is the opening, or what we call this as hole. That hole is called as pupil. That hole is called as pupil. This circular diaphragm itself, that is iris, is opened with a hole, okay, or with a gap, a small gap, okay, that is called as pupil. Now, this small gap or the pupil, what it does is, it either contracts or relaxes to receive the light, okay, means it depends on the intensity of the light. So this pupil responds to the intensity of the light. That's why there is a small hole, okay. The function of the pupil is to do exactly, that is either contract or relax, which depends on the intensity of the light that is being coming from the object, okay. Now, the function of the iris is to control and regulate the amount of light entering the eye by adjusting the size of the pupil. As I told you, the iris and the pupil goes together. So the function of the iris is to control, okay, control and regulate, both it does, okay. It controls and regulate the amount of light that is entering through the cornea. It is entering, the amount of light is entering, okay. So it controls and regulates the amount of light which is entering. So how does it control and regulate? That is with the help of pupil. Because the light intensity is high and the light intensity is also low. Depending on that, the pupil will respond, okay. So it controls and regulates the intensity of light that is entering the eye. Now, when the intensity of outside light is high, the pupil contracts. Now you can see here, the light which is coming through the cornea is entering through the pupil, okay. When that intensity is high, higher the intensity, what happens? The pupil, you can see this pupil, right? This pupil, this will contract. Contract means it will be closer, it will contract. When the intensity is high means this pupil will contract, okay. It will, you can see here, these two will contract, okay, when the light intensity is high. Now, when the light intensity is low, the pupil expands. As I told you, suppose if the light intensity which is entering through the cornea, it is low, then what happens? This pupil will expand, okay, this pupil will expand when the light intensity is low. This pupil will contract when the light intensity is high, okay. So this is the function of the pupil, and you know that pupil is nothing but a hole on this iris. That's why iris and pupil, okay, this pupil is nothing but an opening or a hole upon the diaphragm, that is iris, okay. So the main function of the iris and the pupil together is to control and regulate the intensity of light that is entering through the cornea inside the human eye. Now, you can see behind the pupil, that is next, that is third, there is a convex lens called eye lens. So you can see here you can see this is eye lens, okay. The blue color water I have shaded, this is nothing but eye lens, very important. And God has given us the natural eye lens which is a convex lens. So whatever the lens that we have, okay, that is a convex lens, okay. You know the convex lens, right? It forms real, inverted and diminished image. Now why we don't see inverted image, that's a different thing. I will discuss that later, okay. But the properties of the convex lens is real, inverted and diminished or lesser size of the object, that is that's the image, okay. Now that is the eye lens, okay, that is the fifth one. Now this eye lens is nothing but what? This eye lens is made up of fibrous jelly type material, very very delicate, okay. It is made up of fibrous jelly type material, this eye lens, okay. And it is not like what we get, see the convex lens, okay, that we will use in the physics laboratory or wherever we use the convex lens, that is made up of glass, okay. It has the same property, but it is biologically made by some certain jelly like substance and using also some fibrous materials, okay. Now that is eye lens, which is a convex lens. Now since you have this eye lens to be a convex lens, it is associated with what? Focal length, right? It is associated with focal length and converging power. Why? Because convex lens is converging lens, right? So it is having converging power and focal length. Both are adjustable. Okay, since in the lens also while doing the experiments we can adjust, right? So that is the focal length and the converging power of this eye lens is also adjustable depending on how we are able to perceive the object or how we are able to see the object at what far distance and what is the amount of light intensity that is entering the human eye. Okay, now the focal length and the converging power of the lens is not fixed, which means it is adjustable because its curvature can be modified to some extent by ciliary muscles. Now you can see here, students, this convex lens or this eye lens is supported by two muscles. Okay, top and bottom you can see the two muscles which we call it as ciliary muscles. C-I-L-I-A-R-Y, ciliary muscles. And the function of these ciliary muscles is to support the eye lens properly, and also this ciliary muscles also helps in the movement of contraction and relaxation. Okay, why? Because this eye lens has to modify itself with respect to focal length and converging power. For that reason, these ciliary muscles will also support to contract and relax. Thereby, the pupil also will respond in the same way. Okay, so that is ciliary muscles. Now these ciliary muscles, okay, when they are relaxed, so when the ciliary muscles are relaxed, when these ciliary muscles are relaxed, okay, when they are relaxed means this eye lens becomes thin. This eye length becomes thin so that its focal length increases. Its focal length increases. When the eye lens becomes thin, its focal length increases and its converging power decreases. So when these ciliary muscles, when these ciliary muscles are relaxing, the eye lens becomes thin. When the eye lens becomes thin, its focal length increases and the converging power decreases. Then let us go opposite way. When the ciliary muscles contract, okay, when they contract, when these ciliary muscles will contract, the eye lens, that is convex lens, it becomes thick. When it becomes thick, what happens? The focal length decreases and the converging power of the lens increases. Okay, now that is the function of the ciliary muscles. That's why it's very important that the ciliary muscles will support in contraction and relaxation of this eye lens. I repeat, when the ciliary muscles relax, the eye lens will become thin, its focal length increases and its converging power decreases. Now when this the ciliary muscles will contract, the focal length becomes thick, okay, the lens becomes thick, that is the eye lens, and the focal length decreases so that the converging power increases. So that is the function of ciliary muscles. Okay, so it supports the eye lens. The ciliary muscles will support the eye lens. Okay, now behind the eye lens, you can see at the back part of the eyeball there is a screen called retina. Now behind the eye lens, behind this eye lens, okay, you can see here this full is retina. Okay, that is, you can see along the iris, okay, that is the lining, that is full is retina. Retina is very important. Okay, now this retina is very important. Why? Because upon the retina, that is on the membrane of the retina, we will receive the image of the object. Okay, retina is very important. Okay, why? Because retina helps to receive the image of the object. Okay, whatever the image is formed, it is formed on the retina. Now this retina is again a delicate membrane. Okay, it is a delicate membrane. This retina is a delicate membrane which covers entire back portion of the eye lens. Okay, it covers entire back portion of this eye lens, that is convex lens, that is covered by the retina. Okay. Now this retina is a very, as I told you, it's a very delicate membrane and it contains enormous number of light sensitive cells. Okay, this retina consists a number of light sensitive cells. Okay, and those cells are in the form of rods and cones. Okay, they are in the form of rods and cones like this. Those cells are in the form of rods and cones. Now, these two cells, separate cells, that is rods and cones, which constitute the retina, they have a specific purpose. Okay, because rod cells will do certain activity and these cone cells are specifically designed to do certain task. Okay, now these rod type cells respond to the intensity of light. As I told you, these rod cells, it responds to intensity of the light. How much intensity, that is whether the intensity is less, whether the intensity is high. To that, these rod cells on the retina will respond. Coming to the cone cells will also always respond to the color of the light. Okay, these cone cells will respond to the color. So one rod cells will respond to the intensity. Next, the cone cells responds to the color of the light. Means we are able to distinguish the various colors that we can see, right? So that is decided, or that is given by the cone type cells. Okay. Now we can see the intensity of the light, whether it is less or high. We can see that is decided, or that the work is done by the rod type cells. Both these cells, rod type cells and these cone type cells, are present on the retina. Okay. Moving further. These cells gets activated upon illumination and generate electric signals. Now what happens? The rod type cells and cone type cells will both receive the intensity, and that is the intensity and the color of the object. Okay. Now that image is formed. That image is formed on the retina. Now, as I told you in the convex lens, the image is real and inverted. But we will not see inverted image, right? If you are seeing any building, we will not see the upside down. Okay, it is not inverted. Why it is not inverted? Means you can see here, this retina is connected by optic nerve. Okay, it's connected by optic nerve to the brain. Now this, whenever the image is formed, that is being converted as electrical signals or impulses. Okay, and those impulses are sent to the brain. The brain will recognize, or the brain will decide, like the object what we are saying is that particular object, and that brain will also decide that the image has to be viewed, or it is recognized as it is. Even though the convex lens does the part of inverting the image, through this optic nerve, that inverted image is sent to the brain, and the brain will easily recognize and make that object to be visualized as it is. Okay, so that's why we will not get the inverted image. Why? Suppose if you are using the convex lens in the physics laboratory, it is not so. Why? Because that lens is not connected by any optic nerve, right? So that is what? A non-living thing. Even though it does the object of inverting the image. Now, whereas this optic nerve, since it is present in the eye, okay, that will connect this retina, or the image formed on the retina is sent to the brain via optic nerve. How? Means through the impulses, okay, to the brain, and the brain will recognize the particular object as it is. Okay, the image formed as it is. That's why we will not get the inverted image. We will see the image as it is, but the image is what? Smaller, diminished image we will see. We will not see the bigger image, right? As it is, we will get the diminished image. Now, so that is the function of the optic nerve. The space between the cornea and the eye lens is filled with viscous liquid called aqueous humor. You can see here, this 9, there is aqueous humor. How to pronounce this? Aqueous humor is a fluid or a liquid that is present in between cornea and the eye lens. So in between the eye lens and the cornea, there is a liquid or a fluid which is present called as aqueous humor. One more is present called as vitreous humor. You can see as vitreous humor. Now vitreous humor is also a transparent jelly kind of a thing which is present, okay, which is present in between eye lens, okay, eye lens and the cornea, okay, which is between the eye lens and the retina. So vitreous humor is a transparent jelly material which is present in between the eye lens and the retina. Aqueous humor is present in between what? Cornea and the eye lens. Vitreous humor is present in between eye lens and the retina. Okay. Next, moving further, we all have the eyelid, right? The eyelid, what it will do? We will blink the eyes, so it will close and it will open. It can be compared to the shutter of the camera. Okay, the camera has the shutter, right? So we can close it and we can open it. Similarly, the eyelid does the operation of closing and opening. So when the eyelid gets opened, the first part what we can see is the bulged one, that is the cornea, right? Now moving further, the least sensitive spot on the retina. You can see here, this is the retina. You can see here one red dot. This is called as the least sensitive spot. There is no sense only. That least sensitive spot is called as the blind spot. Okay, it is called as the blind spot. You can also see that at the blind spot, the optic nerve is connected, right? Now, this blind spot is the spot at which the optic nerve connects the eyeball, or it is connected to the eyeball. Okay, which means this eye is being connected by a optic nerve. Okay, that is the optic nerve is connected to the eyeball at which spot? That is blind spot. So this blind spot is not only the most insensitive part on the retina, but it also is the point at which the optic nerve gets connected to the eyeball. Okay, so that is about the blind spot. Okay, now one more thing. As I was telling you, this iris, okay, this third naming, that is this iris along with the pupil, it also contains certain colored pigments. Okay, it contains some colored pigments along its lining, along the diaphragm, this iris, along with this pupil, it is containing some colored pigments. These colored pigments are responsible for the color of the eye. Not the color of the object. The color of the object and the intensity of the object, that is the light, is dependent by the retina. That is it contains what? Rods and cones. So these will respond when the light is coming from the object. Okay. Now here this iris along with this pupil is also having certain colored pigments. These colored pigments are responsible for the color of the eye. Okay, it helps for the color of the eye. Okay, what is that? Iris and pupil. Now, these are all the various parts of the human eye and what operation it will do. Okay, so it all depends on the cornea, that is, it acts as a window when the light enters from the object. Okay, so this is the explanation about the structure of the human eye, its various parts, and what are the functions of the various parts. Thank you. So, after understanding the various parts of the human eye and what exactly those parts will function. Okay, now let us move on to the working of human eye. Okay, now the working of human eye, you can see here just the outline of the eye I have drawn, need not to draw the minute details of whatever the parts. Okay, whatever required we can draw here. Now you can see here, this full is the eyeball and this is the cornea, and I have drawn the lens. Which lens it is? Convex lens. Now see here, you know that the light from the object which is at certain distance will enter the human eye through the cornea. After the cornea, it will fall on the iris, that is on the pupil, and those ciliary muscles will contract and relax, as well as the pupil will respond, okay, either to contract or relax. Now that light has entered the convex lens. The light from the object has entered the convex lens. Now what is the function of the convex lens? The function of the convex lens is to make the image of the particular object, okay, to be a real as well as inverted and diminished, means much smaller, and it will do exactly its operation. Okay. Now the eye lens, which is the convex lens, is capable of doing real, inverted and smaller image of the object. Now why this will happen? I told that while explaining the structure of the human eye, that there is retina or retina, however you call, okay, and that retina is having that the membrane or the layer of the retina is having two types of cells, right? And both are related to the light. That is, it contains rod cells and cone cells. So both types of cells are present on the membrane of the retina. Usually this retina is in the back part or at the back of the eye lens. So that retina, which consists of cone type and rod type cells, they are designed for specific purpose. Okay. Now you can see here, these rod cells which are there on the retina membrane, they respond to the intensity of light, whereas the cone cells respond to the color of the light. Okay. So when they does the operation of the that is the rod cells and the cone cells, when they respond to the intensity and the color of the light, obviously an image is formed on the retina, and you can see here the image is formed. See the size of the object and see the size of the image. The size of the image is lesser than the size of the object and it is inverted. Where the image is formed? The image is formed on the retina. Okay. Now, how do we see the image? We will not see the image inverted, right? If this is the object, we will see the object like this only. We will not see like this. Why? Because when the inverted image is formed on the retina, this retina is connected to the brain via optic nerve at the blind spot, right? So at the blind spot, the optic nerve joins the eyeball. Now this image is sent as electrical signals, or you can also call it as nerve impulses. You can call it as nerve impulses. So the signals are sent to the brain in order to process. Yes, because brain is the thinking organ, right? Now, when these signals or when the image is sent to the brain via optic nerve in the form of nerve impulses, the brain is able to recognize, to process the object as it is. That's why the brain will tell that whatever the image that you have received, okay, is that particular object only, as well as we perceive the object like that itself. That's why if this is the object seen from the far and we get the image of this particular object as it is, okay, it is not inverted. We get inverted only on the retina, okay, but when this image information is sent to the brain via optic nerve, the brain is able to recognize that this image is like this, okay. That means whatever the object that the eye visualizes, whether at far distance or whether the near distance, the image what we are getting is, means we are getting as it is. Why? Because the brain does its operation, okay. The brain processes the information and perceive the objects as it is, as they are. So this is the working of the human eye. Thank you. So moving to the next concept, that is persistence of vision. I think this you would have learned in your primary classes also, but since it is related to the human eye, okay. Now how do we perceive any object? Till what time or till what fraction of the time it will persist in the human eye, okay. Now that is called as persistence of the vision. Now you can see the continuous sensation of eye for some time. The sensation of the particular, the object that we receive through the light, okay, that the image of that particular object or that particular sensation will stay for some time, okay. The continuous sensation of the eye for some time, even though the object is removed, even if you remove the object, when you see the object through the eye, the image of the object will persist for some time. So that is called as persistence of vision. Now that continuous sensation will persist only for about 1/16 of a second, means the image of the object persists on the retina. So the retina is having the capability to persist the image of an object for only about 1/16th of a second. Means in that very small amount of time, the eye is able to hold the image of the particular object that we see. Now what happens if you keep seeing all the various objects that we see around, right? Because we are not confined, the eye is not confined to see only one particular object the whole 24 hours, right? We will see everything. So every object that we see will persist only for about 1/16th of a second. Now please don't confuse this that I have seen a particular object and 2 or 3 years before, but I could still see, I could still get that the image of that particular object. That is only because of the brain, because the brain has the memory. Okay, that is a different concept. Okay, now only I am speaking about eye. As soon as you see the object, the eye is able to hold that particular object for some continuous interval, that is for about 1/16th of a second. Okay, so that is known as persistence of vision. Now we can see this persistence of vision in cinematography or in motion pictures, or while we see the movie in a theater. Okay, when we go there, usually the movie is like 24 frames. In those 24 frames, we have the characters, one slide to another slide to another slide. So like that we have 24 frames. So when these 24 frames will move in certain interval of time, say 1 second. Now how this eye is able to recognize frame to frame. Okay, now see here, when the eye is visualizing the first scene or the first frame, now whatever the characters that he is doing, whatever the characters that are there, using that audio, that is dialogues, the visuals, everything is seen, before it goes to the next frame, this particular first frame will persist only for how much? 1/16th of a second. After this frame, the eye is able to see the second frame, but this first frame is stored in the memory. That is the function of the brain, but only the eye is able to hold that particular first frame, or whatever the characters that are you can see on the screen is the eye is able to hold for 1/16th of a second. So like this, since the frames are moving continuously, you can see the movie, the bits and pieces, that is the bits of the frames are moving continuously, right, in the movie for about 2.5 hours. So the eye is able to visualize all the frames depending on the persistence of vision, so that we are able to connect each and every frame, and the brain is able to process each and every frame, so that we get the movie, we understand the movie. Okay, so that is one of the that is the beauty of this persistence of vision. Okay, so this is about the persistence of vision. Now, while I was explaining the structure of the human eye, we came across the two types of cells that is present in the retina, that a membrane of the retina. That is, one is rod cells, the other one is cone cells, right? Now, they are designed for specific purpose. The rod cells responds to the intensity of light. The rod cells usually responds to the intensity, whether the intensity is high or low, whereas the cone cells will respond to the color of the light. Now, what happens when the eye is not able to respond to the color of the light? When the eye fails to respond, or when the eye fails to recognize a particular color of the light, leads to a problem or a defect called as color blindness. Means the eye is blind, and the eye is blind for certain color. Okay, now why this is happening? Because of the concentration or the percentage of cone cells that is present in the retina. The percentage of cone cells present in the retina has to be at certain level. When it drops to or when it decreases from that particular optimum level, so what happens? The person is prone to color blindness, or the person will get the color blindness. It is a condition when a person cannot distinguish between different colors. We see different colors, that is the predominant colors that what we see in the white light, right? Violet, indigo, blue, green, yellow, orange, red. Among these colors, if a person is having color blindness, he is not able to distinguish between green and red or blue and violet, like that. Okay, for some color he will say the other color. So this is because he or she is facing the color blindness problem. Now, as I told you, the reason is being the deficiency of the cone cells being present in the retina. Even though you have sufficient rod cells to support the intensity of the light, due to the lack of cone cells that is present in the retina, the person is unable to see the color. Okay, that's why he faces the color blindness. So this is because of the lack of cone cells in the retina. Now this problem, that is color blindness, could be seen more in males than in females. Okay, and this happens to be because of, or it is caused due to the inheritance. Means it's a genetic disorder. It happens to be a genetic disorder, or it is caused due to inheritance. So this is how we view the different colors, and what happens if we have the, we cannot view any particular color or any colors, that is because of the color blindness. And why that happens, we have all seen. Thank you. Now, moving to the next concept, that is power of accommodation of human eye. Means, we see the objects, and the objects may be near, or the object may be situated at a far distance. So what should be the power of the human eye in order to see that particular object as it is and get the image of that object very clearly? Okay, so that is something which is related to the power of accommodation. Accommodation means what? Accommodating the object as it is. Okay, means the power of the lens, it is dependent on the converging power of the lens. So how exactly is the converging power? On what factors it is dependent, so that there is the power of accommodation. Now you can see here, what is power of accommodation of human eye? The ability of the eye to observe objects distinctly. To observe the objects distinctly. Distinctly means separately. Means we are observing. If I am observing one particular object, so I am able to see that object. If I shift my vision to the other object, I am able to see that particular object. So distinctly, the eye is capable of observing the objects distinctly, situated at different distances from the eye, because not all the objects will be situated at the same distance. Few objects will be situated at different distances from the eye. So that ability of that eye to visualize or observe the objects, which are objects distinctly situated at different distances, is called the power of accommodation of human eye. Now, why this happens? What is the reason? I have explained in the structure of the human eye, that is, it is due to the change in the focal length of the eye lens. We have the eye lens which is convex lens, and as I have told you, it can be adjustable. So when the focal length is adjustable, or if it is modified, even the converging power of the lens can also be modified. Now, this is due to the change in the focal length of the eye lens due to the action of ciliary muscles. As I told you that this change in the focal length or the converging power is mainly because of the action of ciliary muscles. Okay. Now, let us see the two different scenario here. One is the object is far. You can see this eye. Eye means observer. You can see the object may be a tree. Okay, which is at very, very far distance. Now, if you have the power to see that, okay, now what happens? Usually, the eye, when it sees the object at a very far distance, okay, the ciliary muscles are relaxed. Usually, the ciliary muscles will be relaxed when you see any object which is at a very far distance. Now, when they are relaxed, what happens to the eye lens? Eye lens will become thin. Okay, both are interconnected. Everything is interconnected here. When you are seeing the object at far distance, ciliary muscles will go to the relaxation mode. Eye lens will become thin. When the eye lens become thin, its focal length increases. When its focal length increases, its converging power decreases. Why? You know that P is equal to 1 by F. Both are inversely related. So that's why increase in the focal length will decrease the converging power, which means more the object is at a very far distance, the lesser will be the converging power of the eye to see or visualize that particular object. So that's why we use the word it is unaccommodated. It cannot be accommodated. The main reason being the converging power of the lens has gone less. Why? Because of the increase in the focal length. Why the focal length is increased means the object is at very far distance, right? So its power the converging power has become less. So when the converging power decreases, we use the word unaccommodated. It cannot be accommodated. Okay. Now this is the first case. Now coming to the second case, you can see here the object is near. Here the object was very far. Now see here the object is very near to the observer or the eye. Now what happens? Just the opposite way. Here the ciliary muscles got relaxed. Now you can see here the ciliary muscles are contracted or it is tensed. There is some tension in the ciliary muscles or it gets contracted. What happens when the ciliary muscles gets contracted? The eye lens will become thick. So here it was thin, here it is, the eye lens will become thick. When the eye lens becomes thick, what happens? Its focal length decreases. So when there is decrease in the focal length, because the focal length and the converging power, they are inversely related, the converging power increases. So we use the word it is accommodated. Okay, power of accommodation. Here it is unaccommodated, here it is accommodated. Why? Because the converging power has increased with the decrease in the focal length. Why the focal length is been decreased means the object is at very near. Here the object is at very far. So focal length is more, here focal length is less. When the focal length is less, what happens? The converging power is more. So that increase in the converging power when the object is at a near distance will help in accommodation. So that's why we use the word it is accommodated. So should understand the different conditions when the power of the human eye is unaccommodated, when the power of the human eye is accommodated. Okay, moving to the next. What do you mean by far point? Now just assume that you are observing a tree which is at a very far distance. Still you are able to recognize that it is a tree. And still you are able to see the proper image or get the proper image of the tree. You will be able to observe the tree as it is without any blurred image. So that is called as far point. Far point means how much far is the distance or the object being situated. Okay, still the eye is capable of recognizing that particular object or the eye is capable of receiving its image. Okay, when the object is seen at very far distance and that object is seen very clearly also. Okay, it is being visible or it is seen clearly. It is called as the far point, the most distant point. The more distant means far distance, the more distant, D-I-S-T-A-N-T, not distinct, it is distant point at which the object is seen very clearly. Okay, it is called as far point, denoted by capital F. Don't confuse this capital F with the principal focus. Okay, that is different. Now, for a normal eye, means without any defect you have, the eye is normal. For a normal person having a normal eye, far point lies at infinity, in the sense that you cannot predict the image to be not seen, okay, or you cannot predict the image of a particular object beyond your visual capabilities. So that is not so. Here for the normal eye, far point lies at infinity means that object is at very far distance. Still you are able to see that object and get the image of the object properly. So that is the meaning of it. Okay. So for the normal eye, far point lies at infinite distance, means a very far distance. Now coming to far means opposite word is near. What do you mean by near point? The closest point. Near means closest point at which the object is seen very clearly. Now what happens? You bring the same object which is at very far distance to certain distance or the closest distance at which you are still able to see the more get the clarity of that particular object. Very clearly you can see. So that least point or the closest point at which the object is seen clearly is called as near point. Okay. Now you understood far point and near point. Now for a normal eye, near point is called. It is for a normal eye, the least distance or the near point at which you are observing the particular object, it is called as least distance of distinct vision. Least means less. Distance means at very less distance you are seeing the object. Okay. Distinct means that object is distinct. Right. It is not like other object. So it is separate entity. So least distance of distinct vision. Okay. Near point as observed by the normal eye is also called as least distance of distinct vision. So this is something related to power of accommodation of human eye. Now, power of accommodation of human eye as we were discussing. So here comes the range of vision. Till now we have discussed about the near point as well as the far point. Now what do you mean by range of vision? The distance between near point and the far point of the eye. Okay, means the object is situated at some distance, very very far distance, at infinity becomes the far point. Now the closest point at which the object can be seen distinctly becomes the near point. That range, okay, that is the distance between the near point and the far point of the eye, it is called as the range of the vision. You should remember this. Now let us see in same power of accommodation. Now you are having a person who has a normal vision. A person has a normal vision. Okay, there is no defect. For that eye, you can see the least distance of distinct vision. The least distance of distinct vision is also called as what? Near point. That near point or least distance of distinct vision, that is given by small d. Least distance of distinct vision is given by small d, which is equal to 25 centimeter. That is nothing but what? At that particular focal length, okay, you are getting this least distance of distinct vision. The d is equal to 25 centimeter means that small d is equal to the focal length itself. Okay. Now that normal for a person having the normal vision is having this value. Now what is the maximum power of accommodation? Okay, you know that the formula which relates the converging power of the lens or the maximum power of accommodation of human eye is equal to, the main formula is 100 by f. Here that focal length is nothing but the small d, that is least distance of distinct vision. That standard value is 25 centimeter. That d is 25 centimeter fixed. Okay, that is for what? That normal vision, a person having normal vision. Now if you substitute p is equal to 100 by d, which is equal to 100 by 25. If you simplify, you will get power is equal to 4 diopter, or p is equal to 4d. So what it indicates means a person with a normal vision has the near point or the least distance of distinct vision, small d, having it, which is equal to 25 centimeter, will have the maximum power of accommodation of 4 diopter. Okay, this can be asked for in MCQ or for short answer questions. Okay, for short answer question definitely like a statement problem it will be asked. So remember that the leaf for small d is equal to 25 centimeter. That is, a person with a normal vision will have the power of accommodation to be equal to what? 4 diopter. Or vice versa. A person having a normal vision has the power of accommodation of 4 diopter. What is the least value of least distance of distinct vision, which is equal to 25 centimeter. Thank you.